Hello students, and we're back to working on Unit 2, and this is now Lesson 15, Solving Systems of Equations by Elimination. So we just got finished looking at how to solve systems of equations using elimination. So this is part 2. It'll get a little bit harder, and so we'll just jump right in and see what's going on here. So they're starting out. Is this still true? Here's an equation. 50 plus 51 equals 50, or 50 plus 1 equals 51. Perform each of the following operations and answer these questions. What does each resulting equation look like? Is it still true? So we're going to go and look at this thing and see what's going on here. And add 12 to both sides of the equation. Add 10 plus 2 to the left side of the equation and 12 to the right side. Add to the equation, 4 plus 3 equals 7 to the operation of 51 plus 1 equals 51. Alright, so let's just start with that one. So we're going to go. We can start by writing down some information here. So let's see, 50 plus 1 equals 51. That is pretty much always true. Alright. We're going to start by adding 12 to each side. So if I add 12 to both sides, okay, so 50 plus 1 plus 12 equals, well, 51 plus 12, that would be 63. And we can go through and add these up if you want, and we can look at 50, a 1, and a 12. So 2 and 1 is 3. 5 and 1 is 6, so yeah, 63 equals 63. We can go back and look at this. It says add 10 plus 2 to the left side and 12 to the right. So let's see, plus 10 plus 2 and plus 12. So 50 plus 1 plus 2 plus 10 plus 12 equals, on the other side, that looks like it's 75. So we can count this up. 1 and 2, that's 3. 3 and 10 is 13. 13 plus 12 is 25. 25 plus 50, it's still 75. We still have maintained our equality. Alright, then add the equation 4 plus 3 equals 7. Alright, let's see what that looks like. Plus 4 plus 3 plus 7. So now I've got 50 plus 1 plus 2 plus 3 plus 4 plus 10 plus 12 equals, let's see, 75 plus 7. It looks like it's going to be 82. So we can go through this and see what's going on. 1 and 2 is 3. 3 and 3 is 6. 6 and 4 is 10. 10 and 10 is 20. 20 and 12 is 32. 32 plus 50 is 82. So as long as we're adding the same thing to each side, no matter how you want to state it, it's always going to maintain that equality. Write a new equation that when added 50 to 51 gives a sum that is also a true statement. Write a new equation that when added 51 gives a sum that's a false. Well, the only way it's going to be false is if you add something like 10 equals 11. Alright, that's the only time it's not going to be true. As long as the things that you're adding to each side are the same amount, like 12 and 2 is, or excuse me, 10 and 2 is 12, 3 and 4 is 7, 12 and 12, as long as you're adding the same amount to each side, you're going to maintain equality, and that's all there is to it. It's when you start doing something like this and you add different things to each side, which you'll actually no longer have that equality. Alright. 15.2, classroom supplies. A teacher purchased 20 calculators and 10 measuring tapes for a class and paid $4.95. Later she realized she didn't order enough supplies. She placed another order of 8 on the same calculators and 1 more of the same measuring tape and paid $178.5. The system represents the constraints of the situation. So here's what she did. She had 20 calculators, 10 measuring tapes, spent $4.95. She then went back and got 8 more calculators and 1 more measuring tape, right? And she had that up to 178.5. All right. In this situation, do the solutions in the first equation mean? Well, the first equations in the first means 20 times C is the cost per calculator, M is the cost per measuring tape. Same thing down here, cost of calculator and cost of measuring tape. So these two should be working together. Find the solution to the system, explain, or show your reasoning. All right. Well, we don't know the cost of each. We have 2 variables, the cost of the calculators, the cost of the measuring tapes. But we know each time that if I bought 20 calculators and 10 measuring tapes, I get this amount. If I buy 8 calculators and I was to buy 1 more measuring tape, then it would cost this much. So we can go through and we can do some ways that we can try to figure this thing out so that we can find a way to go and solve this. So what we can do, now they did, to find the solution, explain, to show the reasoning. Okay, so what I can do is I can use either elimination or substitution on this. This is really what it comes down to. The 2 methods that we know so far. There's 2 methods that I can use to solve this. Find the solution of the system, explain, or show your reasoning. To be reimbursed for the cost of the supplies, the teacher records the items as 28 calculators and 11 measuring tapes, amount 673.5. And of course, if you add 495 and 178.50, you do come up with 673.50. Right? So now they go back down here and they want to write all the answers here. So we're going to go through. We're going to go ahead and solve this and figure out what the cost of the calculators and the measuring tapes are. All right. So let's go ahead and start by writing those equations down. So let's see. I got 20C plus 10M equals 495, and then I got 8C plus M equals 178.50. All right. So let's see what that looks like. Okay, so this is what we got so far. Now, what I can do, I don't have any direct substitutions here. Okay, between 8, 20, 10, and 1, I don't have any way of doing an exact substitution. So I'm going to have to go and start to manipulate these a little bit. Luckily, there's a way I can do this. What you're allowed to do is to take any equation, as long as you add or subtract or multiply the same thing on both sides of an equation, you can maintain an equality. So what I'm going to do is I like to get rid of this 10m right here. I can go and multiply the bottom one by a negative 10 and then just do a quick addition. Okay. So if I take this and I simply multiply it by 10 on each side, or excuse me, a negative 10. All right. If I multiply this side by negative 10, I get a negative 8c, negative 80c. I'll get a negative 10m, and I'll get a negative 1785.0. All right, you can check my math there. But if you take each one of these and you multiply by 10, 8 becomes 80, 1 becomes 10, this number becomes 10 times higher, and since I multiply by 10, I have the negative sign there. All right, I'm just going to bring that other one right down next to it. I'm not going to change that one. And you can change the order. You have this one on top. Down here, I can have the other one on top. It's okay. It doesn't matter. All right, it'll still add up the same amount. All right. So I still got 20C, 10M, 495. I just manipulate the bottom one so that I will cancel out the measuring tapes here. So if I look at this thing, what do I got? Well, I have a negative 80 and a positive 20. So that's a negative 60C. The M's will cancel. And then this side I have to do a little bit of math. All right, so let's go pull up our calculator. All right, clear out everything. And I'm going to take a negative 178.50, or 5 in this case, and I'm going to add to it, oops, let me do a sign change here, there we go, and I'm going to add to that 495. Oops, let's go and clear that out again. It didn't work before. 178.50. All right, and I add 495. I get a negative 1290. Right? Now you can see what's going on here. I need to divide by negative 60 each side. Negative 60, negative 60. And when I do that, divided by 60 negative. 2150. So the cost of a calculator is $21.50. Alright? $21.50. Now that I know that, I can go up to any one of these calculators up here, any one of my originals, or any of these ones I massaged a bit, and I could go and do the same math. I'm going to choose this simple one right here, because that's about the smallest value I have. I know that 8 times the cost of the calculator is $21.50, plus 1 measuring tape equals $178.50. Alright, so I'll take that number times 8. 172 plus m equals 178.50. Now remember, I'm just solving for m at this point. So I subtract 172 from both sides. M equals, so 178.5 minus 172, 6.5. 6.5. Alright, so there's the two variables that I just solved for. And I used elimination. And what I like to do is I want to go to the very top here and I want to go and check my work. Alright? So let's substitute in there. I'm going to go and take 20 times 2150. Let's see, right there. Let's see, times 2150, and then I'm going to add to that 10 times 650, 6.5. Oops, my order of operations didn't hold out. This is why we don't use our calculators on our cell phones. The order of operations doesn't work. We'll need to use grouping symbols. So 20 times 21.5 in grouping symbol plus grouping symbol 10 times 6.5 grouping symbol equals 495, which is exactly what I'm supposed to be getting. So yep, I am very confident that this is the correct answer. Alright, and let's see. And we pretty much explained everything that we did here in all of our talk here. And you can actually go ahead and talk about this. 28 calculators. So let's see. I'll go and clear everything. If I had grouping symbol 28 times 21.5 grouping symbol plus 11 right here. Excuse me. Grouping symbol 11 times 6.5 grouping symbol 673.50. 673.50. Yep, it works. All right. So yep, everything worked out on that one. Let's see. Solve each system equations without graphing and show the reasoning, then check your solutions. Okay, so we have a bunch of numbers here. Let's go through those. And let's start with the first one. Now this one you can almost do in your head because you got small enough numbers here. You got 2x and a minus 2x, and then the 3y, 4y, and the 7 and 14. You can always do this one in your head. Well, if you add these up just to do elimination, these go away. So you've got this sum right here. Well, what's 3y plus 4y? Well, that's just 7y. And then 7 plus 14 is 21. So what you have now at this point is just 7y plus 21. Divide both sides by 7 and y equals 3. Right? And then if you go back here, y equals 3. So you have 2x plus 3 times 3 equals 7. All right. You're basically going to go and substitute in the 3 you just found into this y. All right. So you have this. All right. So 2x plus 9 equals 7. Subtract 9 from both sides. 2x equals, well, what's 7 minus 9? Well, you get a negative 2. X equals negative 2 divided by 2, which is negative 1. So negative 1 comma 3 should work. Let's try the second equation to check our work. So 2 times a negative 1. 2 times a negative 1 plus 3, 4 times 3. And does that equal 14? Let's check our work there. All right. Negative 1 and 3. Let's see. Let's go back here real quick to make sure I did my work right. 9, 2x, 3 equals negative 1. Let's see. Each solutions. Okay. And negative 2x. Oh, that needs to be a negative right there. All right, negative 2x. Okay, so what do we got? I wrote down everything. Negative 2x plus 4y equals 14. So negative 1 times negative 2 is a 2. 3 times 4 is a 14. Or excuse me, is a 12. And so 2 plus 12 does in fact equal 14. So, yep, I'm very confident that that's the solution on that first little part. Now, let's see. Let's go to B here. Now in B, you can see that if you look at these up and downs here, the plus 3y and the minus 3y kind of cancel each other out here. This one's pretty straightforward. So let's go and just use elimination here, and we can be done with it. So if you add these, you're going to get a 5x right here. The 3 y's are going to cancel, and then on the other side you'll get 3 plus 7, which is 10. Right? So here we are here. So 5x will equal 10. Divide both sides by 5. X equals 2. All right? Now that we know that x is 2, if x is 2, we can solve for the rest of these things. So we have 2 times 2 plus 3 times y equals 7. All right, let's see if we can find out what y is. So 2 times 2 is 4. Plus 3y equals 7. Subtract 4 from each side. 3y equals 3. Y will equal 1. All right. Now y equals 1, let's go back to our original equations again. Let's see if we can solve this. All right. Did we figure out what x was? Yes, it was 2. All right, so let's try it on this bottom one. 3 times 2 minus 3 times a 1, is that equal to 3? That's the question mark. Okay. So 3 times 2 minus 3 times 1. Well, 3 times 2 is 6. Minus 3 times 1, which is 3. The question mark, does that equal 3? Well, yeah, 3 equals 3. 6 minus 3 is 3. So, yeah, that's another good solution. We found it with one equation, and we checked it with the other. All right. Now on C here, you don't have a really, that elimination didn't like fit itself like right here or right here. This one you can do elimination or you can do substitution. Just for fun, let's do a substitution here because it should be pretty straightforward to do a substitution on that one. So let me get a fresh sheet of paper here. And 2x plus 3y equals 5. And 2x plus 4y equals 9. All right. So let's just do a substitution on that one, or substitution. All right. So you see that I got 2x and 2x. They're the same sign, the SIGN sign. I can't just substitute if I wish. I can do that by just simply isolating what the 2x here. I want to solve for 2x, so I can substitute it in right here, this upper one. Well, if I substitute for 2x, that means I got to move the 4y over here, so I'm going to subtract 4y from both sides. Cancel, cancel. So that equals 9 minus 4y. Okay. Now I'm going to substitute in this top one. So instead of the 2x, I'm going to have 9 minus 4y. All right. That equals 2x. Okay. And then I'm going to add 3y. And that's going to equal 5. Okay, so let's go through this. The grouping symbols don't do much for me. All right, and I look at this, I say, oh, I can add these two y's here. All right, negative 4 plus 3, that's just simply a negative y. And I'll have a 9. And then on the other side I have a 5. And remember, I'm solving for y. All right, so let me add y to both sides. And I'll subtract 5 from both sides. I like doing that way because that way I'll get a positive y. And I'll have everything else on the other side, and I can figure out what the sign is. Cancel, 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 cancel. I just got a y on this side. And then 9 minus 5 is going to be 4. So what did we get out of this? Well, so far all I've done is I've solved the y value of 4. All right, so I'm looking like, it looks like that right now. I don't know what the x is. Now I can just simply substitute back in and solve it and then check with the other equation. So let's take the top one to solve for x and we'll check with the bottom one. So 2x plus 3y, which is 3 times a 4, equals 5. 2x plus 12 equals 5. Right, and I'm going to subtract 12 from both sides so I can isolate the 2x on one side. 5 minus 12 is a negative 7. So 2x equals a negative 7. I divide both sides by 2. X equals a negative 3.5. So 3.5, and it's going to be a negative, right? So I'm going to put a little negative sign there, just so everybody knows. All right. Now I'm going to check it with this bottom one and make sure everything works out. So 2 times a negative 3.5 plus 4 times 4, and we have to make sure that it works, that it gives us the value of 9. So let's see. 2 times 3.5, well, that turns out to be a negative 7, plus 4 times 4 is 16. Well, what's this turn out to be? That's like 16 minus 7, or negative 7 plus 16, however you want to think of it. That does equal 9. So 9 does equal 9. So yeah, we just got done showing it, and this is your solution. Negative 3.5, comma 4. There's the equation for that one. Oh, the solution for that equation. And again, that was substitution, the way we did that one. And look at this one. Let's see. Anything interesting here? Well, I got no exact numbers, but I can do some substitutions on this. And I don't have things lined up where I can just do a simple addition. So elimination is not going to work here. I could do elimination. I could do substitution and try to figure it out. I'm going to go and do this. I'm going to do elimination. And I'm going to do that by multiplying the top one here by a negative 3. If I do a negative 3, I'll get a negative 6 right here. And then these rest will fall, and I can just add them up. So let's just do a little, let me start by writing down the equations on some paper. And we'll start doing our work on paper. All right, and I got 6x minus 5y equals 20. Okay. So what do I got? Here's my equations. Well, like I said, I'm going to try to eliminate right here along the x's. I'm going to multiply everything on the top by a negative 3. So I'm going to multiply by a negative 3. Okay? All right? That's what that means there, times the negative 3. Well, if I do that, 2x becomes negative 6x. 3y becomes a negative 9y. And 3 times 16 is 48. So negative 48. Now we're going to kind of check yourself. If I got a negative sign, changes all the signs. So positive becomes negative, positive becomes negative, positive becomes a negative. Negative, negative, negative. Okay, I'm pretty sure on that one. All right. And I'm going to keep the same bottom equation. I didn't manipulate that one at all. I'm just going to go and carry it along. There we go. And now I'm just going to simply go through my adds. All right, these will cancel. 9 and 5 give you 14, so that's a negative 14y. And negative 48 plus 20 is a negative 28. All right, divide both sides by the coefficient of the unknown. And it turns out that y equals a 2. Okay. Well, if y equals 2, now I can do it into any of my originals. Now, what I always like to do is find the other part with the originals and always try to go back to the originals, because when you start manipulating like this, you might have an error and you'll just carry it forward. And you'll expose it very quickly if you put into the originals that are unaltered. So let's see. 2x plus 3 times the 2 equals 16. So that's 2x plus, well, 3 times 2 is a 6 equals 16. Subtract 6 from both sides. 2x equals 16 minus 6 is 10. Divide by 2. X equals 5. So I'm thinking that 5 comma 2 is my answer. Now that I found it with that one, I'll check it with the other one. 6 times 5 minus 5 times 2 equals 20? Question mark. All right. Well, what is 6 times 5? Well, that's 30. Minus 5 times 2 is 10. 30 minus 10 is 20. So 20 does equal 20. And yep, we checked it and it works. So that looks like a solution for the last one. All right. And so here's your little summary. And solving an equation with that. When solving a system with two equations, why is it acceptable to add the two equations or subtract one? Remember that the equation is a statement that says two things are equal. For example, the equation A equals B says that A has the same value as another number B. The equation 10 plus 2 equals 12 says that 10 plus 2 has the same value as 12. If this is equal and that's equal, then adding these two together is also a true statement. Right? We can reason the same way about adding variables. If I have these levels of equality, if I add them, I can get this. Negative 2 plus 1 is a negative 1. 1 plus 1 is 2. 17 minus 1 is 16. Right? If I take that one, I take these and subtract one from another. Right? They're showing that you're adding here. They're showing that they're subtracting here. All right? If I have 1 minus a negative 2, that's the same as 1 plus 2. That's a 3. If you have 1 minus 1, right, then that goes away. It's a 0. And 17 minus a negative 1 is the same thing as 17 plus 1, which is 18. And of course, you can eliminate things that way. All right, and then they go through 3e is 18. Therefore, we know that e is 6. 6 is the e value, makes the original statement true. We can now substitute in to find the appropriate f value. And then when you do that, you find out that f becomes 11. So 611 is your solution. Right? And so remember, elimination is a method of solving two equations with two variables where you add or subtract a multiple of one equation to another in order to get an equation with one variable, thus eliminating. And the solution again is where those two lines or those two equations intersect. And substitution is replacing a variable with an expression that's equal to. Right? So that's pretty well straightforward as to what we did there. And next I'll be going on to the practice problems. Thank you.